Well, I never did quite get around to posting that other video I mentioned last time. It's because I'm still not done with it, believe it or not, and I've been delaying my actual car videos for a few months now. Last you would have seen was me putting in the mounts for the rear subframe. Well, while I was making shock tower mounts and preparing the car to fabricate a roll cage, I noticed something. Somehow, one side of the rear subframe mount was noticeably lower than the other, and it became apparent with this crossbar I was going to weld in. Not only that, but when I unbolted the subframe, be it weld distortion or other wizardry, the mounts had pulled out of alignment, and the subframe would not go back in. Unfortunately, there was only one way to fix it, and I spent the next week chopping into all of the work I did before to align this tube again correctly. This, naturally, involved me accidentally damaging a bunch of the surrounding metal and having to fix that as well. But it's done. Now, with a straight edge on either the spring perches, front mounts, or rear bulkhead tube, there is at most 1/10 of a degree of difference, which comes and goes depending on how my angle finder is feeling today. Between the front and rear mounts, as in I placed a straight edge that contacts both rear mounts and placed an angle finder on top, there is 2/10 of a degree of difference between them. I believe that when I was welding in the tubes to the rear bulkhead, I did not properly check to ensure the subframe was level or ensure it was being kept consistent as I made my welds. Either way, it's done, and I'm probably not going to find other issues with it until they're too late to fix.
You got it, big boy? Oh yeah.
Back to the car, I removed the windshield and a number of spot welded brackets under the dashboard. The windshield was damaged by a welding spatter a long time ago, so it's basically junk. However, I was informed there's a company that makes flush mount windshields, and I will be getting one from them. Preparing for the cage also involved removing the roof asphalt sound deadening. This stuff is super flammable, so of course I used a propane torch to remove it. In hindsight, I think a heat gun may have also worked because the adhesive was much weaker than what it was on the floor. With the roof cleaned up, now it truly is time to take a look at installing the cage. With how short and narrow the car is, the seating is a very tight fit. So, temporarily, I tossed in a 20 gauge steel floor with some 1/8 inch thick brackets to hold a seat up. It's at this point, October 27th, that I stop working on the car. As I'm designing my roll cage and planning out my fabrication, I am now reading through the rules of these race sanctioning organizations and notice one crucial detail. They want the main hoop to be one continuous piece of bent tubing. And I don't have a bender. No one I know has a bender. To my engineering understanding, bent tubes are not inherently stronger than a cut and welded joint. However, cut and welded joints have a stress concentration where the two angles of tube meet that must be properly managed in order to retain the full strength of the joint. Otherwise, they would be weaker. This would involve using gussets in the form of short lengths of tube on the inside of the joint. While my plan isn't exactly to track this car, if I ever change my mind, I'll have locked myself out without extensive and expensive framework that would be a nightmare to change. I first asked a nearby shop if they could bend 3 pieces for me, the main hoop and the side hoops. They quoted about $450. The thing is, I could get a manual rotary draw tube bender for $600. There is a Chinesium bender on Amazon for $230 and a die for $330. After taxes, it came out to $600. Unfortunately, at this moment, I am poor and cannot afford it. So instead, I convince my slave to buy me the parts to make a CNC plasma cutter. I then spend the next month or two building a 300-pound portable steel water table to mount it on. I did not record this because I thought it was going to be a quick and easy project that would be overlooked. This, obviously, was not the case. Now, I don't have any footage of what was by far the most intensive fabrication project I have ever completed, and personally, I think it turned out pretty well. Far from perfect, but it certainly works. It's based on this so-called $200 plasma cutter video. Unsurprisingly, not $200, and that was before I got my hands on it. It just never was. I used 1 meter long rails instead of the typical length and modified a couple of the 3D printed parts to allow it to bolt down to a table and use a drag chain. It has electricity come in from a NEMA 14-50 plug. Yes, I said that right. It has a plug on the back in a custom mount I 3D printed. You push the extension cord receptacle into it and it turns on. It's wired straight to a NEMA 6-50 receptacle mounted on the front that the plasma cutter plugs into, and 1 hot goes up to a pair of circuit breakers in the electric control box that powers the CNC computer and a pair of 120 volt receptacles I have mounted on the side. Why? I don't know. It looks cool though. The whole thing is Cerakoted, and in order to get the Cerakote to stick to the receptacles, I had to sandblast the old paint off. This involved, naturally, fixing my sandblaster. I threw in some cheap Harbor Freight LEDs and modified the gun to use a ball valve. The only persistent issues are actually with my compressor. Back to the CNC, it works pretty well. It's not the most precise machine, but it has proven itself as hands down the most useful machine in my shop. Once I figured out good cut settings for my plasma cutter, it began to crank out parts that would have taken me weeks to make without it in minutes. With the plasma cutter done, I'm back to the tube bender. I wanted to save money, so I knocked together a little stand to hold it up with my plasma cutter and a piece of DOM tubing, and then drilled and mounted it to a 2x2 foot concrete paver I had in the back. However, I was reminded that I am bending 2-inch diameter, 1/8 inch wall tubing, and that won't go down without a fight. I learned I need hydraulics. Over the course of the next 2 days, I designed a ram mount. Now, if you don't have access to cheap metal and a CNC plasma cutter, go online, buy this one, don't worry about it. But I figured out my own design. All of this was CNC plasma cut out of a single sheet of 5/16 inch plate, except for the sleeve for the pivot bolt on the carriage. In 4 days, I designed, cut, and welded the whole thing. Testing it on the stand, I realized the pump needs to be on the bottom for the ram to work correctly, and my stand is too flimsy for such a heavy tool. I painted it and got to work making a new stand. This new stand is a roughly 20 by 20 inch, 3/8 inch thick plate with a 5 by 5 inch, 3/16 inch thick tube welded to the top. I plasma cut some pieces to make a pedestal for the stand itself, and I tried grinding it smooth to make it look nice. It turned out okay. Not sure if I'd do it again. Cerakote is pretty expensive for large objects, and I frankly can't keep buying it, so I tried Rust-Oleum high performance enamel. If not for the atrocious spray nozzles, this paint is actually pretty good stuff, and they even sell it in the gallon form that can be sprayed out of a normal paint gun, so I think this is going to be my new default paint. I bolted the tube bender down to the stand, tried bending my first piece of tube. It didn't go very well. Primary issue, the die bites into the tubing, and I'm also getting a decent amount of flattening. This is either from a poorly shaped die, or excessive friction on the follower die, preventing the tube from easily being pulled around the forming die. First thing I tried was polishing the follower and using a higher quality grease. This reduced the amount of flattening and gouging I was getting, but it still needed more. I then sanded down the edges of the forming die to a smooth radius, and all of the gouging in the side of the tubing was gone. That is, until I tried bending a piece, and the follower die block gulled horribly. To fix it, I purchased an aluminum follower block from JMR Manufacturing, who makes the tube bender this knockoff is based on, and it fixed the issue. This bender is still far from perfect though. that leaves us where we are now. I am preparing to bend the roll cage, for real this time, and hopefully finishing up that stupid little side project that has taken me almost a year and a half now in the next week or two. Speaking of the tube bender, if anyone watches this and is looking to buy one themselves, my recommendation would be to purchase the JMR Manufacturing manual bender and their die. I've purchased a U-strap and the follower die from them, and the quality seems well in excess of the knockoff. When you include the follower die I had to purchase to fix my bender, purchasing their bender and die isn't that much more expensive, and I believe will be a much better bender overall with better support for replacement parts. I've come to learn tube benders are very useful tools for fabrication, and that in hindsight, it would have been well worth the money to purchase the JMR. With that out of the way, until next time.